Okay, in our first look at the modulus function, we're going to start off by defining it and then working out how to actually solve equations using it. So, what is the point of the modulus function? Well, first of all, it looks like this. Two lines on either side of an expression, let's say 2x. And the whole point of the modulus function is to force whatever is inside it to be positive. Now, why might we want to do this? Well, as you probably know, using negatives in maths is a pain. Sometimes it's more than a pain if we've got a square root of something. We don't want whatever's inside there to be negative. So sometimes it's useful for stopping things like negative square roots. Sometimes it's just useful for simplifying calculations. So very simply, it just forces whatever is inside it to be positive. Now, this doesn't mean that the function inside it is positive. So let's take 2x minus 1, for example, and I'll throw some moduli around that. 2x minus 1, on its own, doesn't necessarily have to be positive. It's only the fact that we put this modulus sign in there that forces it to be. It's our choice to force it. So if I equate this entire thing to, let's say, 10, this doesn't eliminate the possibility of there being a negative involved in this system. So in order to solve it, we need to solve these things twice. Once we need to solve them assuming this thing is positive, and once assuming that it's not, that it's negative. So in order to solve something like this, we take whatever is in the modulus and we write it out twice. Once with it being positive, so just 2x minus 1, and a once where we take the entire thing to be negative. Couple of distinctions. Taking the entire thing as positive does not mean changing any negative into a positive. That's not what we mean by that. We are just taking it at face value and saying, okay, what we're given is what we get, it's that. Whereas making the entire thing negative doesn't just mean flipping any positives to negatives or vice versa. It means taking the entire thing and throwing a negative sign in front of it. Once we expand all of that out, well, I can solve this side. Add 1 to both sides, 11, divide by 2. My x is 5.5. And if I expand this side out a bit more fully, minus 2x plus 1 equals 10. Minus y1 from both sides. Minus 2x equals 9. And then divide by 2, x is minus 4.5. So I've got two distinct possibilities for what x could be, regardless of what this modulus sign says. In fact, if I put these numbers back in, I get a negative value. But because of my modulus, it's forcing it to be positive 10. So if I put my x is minus 4 back into my original up here, well, 2 times minus 4.5 minus 1 equals 10. 2 times minus 4.5 is minus 9. Minus 1, minus 9 minus 1 is minus 10. And the modulus of minus 10 is equal to 10. So we're not breaking any rules here. It's just self-imposed making something positive. Okay, let's just look at a harder example to finish off. So once again, we have a kind of standard looking equation. The only thing that's scary is our modulus. But once again, we want to do this twice. Once, we just take it at face value, we take it as being positive. So 7x plus 2 equals a half x minus 3. And then we want to take it with the entire thing being negative. So throw a negative outside of a bracket. 7x plus 2 equals a half x minus 3. I'd encourage you to pause and solve both of these. But in the meantime, if I can solve this, minus a half from both sides, 6.5x minus a 2 from both sides is minus 5, x equals minus 5 over 6.5. And then on this side, expand out my minus 7x minus 2, half x minus 3. I'll add the 3 to both sides and minus the 7, I think. or add the 7. So if I add my 7x to that side, I get 7.5x. If I add my 3 to this side, I get 1. And in this case, x must equal 1 over 7.5.